Hello. In this video, we're going to look at sign diagrams. Now, this is a concept that's not initially in your textbook, but is going to be very useful as we go further in the course. So let's take an example function, f of x equals x minus 1 squared times x plus 2 times x minus 3 cubed. Now, you might be able to give a rough sketch of this type of function using your knowledge from pre-cal. We know that there's going to be a root over at 1, so we can put that on the graph. Over at 1. There'll be a root over at negative 2, so we can put that on the graph. And there'll be a root over at 3. Now we know it's going to bounce off of the root at 1, and it's going to pass through the roots at 2, or at negative 2 and at 3. And just judging by the fact that we have a positive 1 there, it's invisible, but we have a positive 1. We know it's going to also be degree 2, 3, 4, 5, 6. So it's going to start over here and end over here. So we're going to have some type of shape like this. It's going to go through these points. We could give it a rough sketch as follows. So we start over here. We go down, bounce off, come through like a cubic, and something roughly like that. So there's our rough shape of what this graph would look like. And we can use our knowledge, of course, of polynomials to do that. But let's do a bit of a different approach, because although rough sketches are important, for this portion right now, I really only want to figure out whether the graph is positive or negative. I want to figure out, is fx above the x-axis or below the x-axis? And the rough sketch definitely gives me that information, because I can see, well, it's above the x-axis here and here, and it's below in this portion. But what if a sign diagram could do the same thing for me without having to deal with all the bouncing and passing through and et cetera, et cetera? So let's go ahead and mark off the points. We've got a point at negative 2, at 1, and at 3, same as before. And on the 1, we're going to write even, because if you notice, when x is equal to 1, this factor is degree 2, so it's an even power. Next, we have to pick a number bigger than 3, because you can think of this like a number line. We want to pick a number over here, so like 4, 5, 6, something bigger than 3. So let's test maybe 4. And we want to find f of 4. When we plug it in, we get 4 minus 1 squared, 4 plus 2, and then times, running out of space here, times 4 minus 3 cubed. All right, so if we work that out, we get 3 squared times 6 times 1 cubed, which, well, all I really care about is whether this overall quantity is positive or negative. So this is positive, squared is positive, times a positive, times a positive. So this overall is going to be a positive number, which means here we're going to put the plus sign. Then when we go over the 3, because it's an odd power, we know the graph goes from being positive to being negative. So we put a negative sign. When crossing over the 1, we know the graph is negative and stays negative, because it's an even power, and so it bounces off and stays negative. When we cross the negative 2, we know it's an odd power, so it's going to go from being negative to being positive. Well, there you go. The graph is positive in this portion and this portion of the number line, and negative over here. And notice we didn't have to worry about the overall degree of the polynomial or look at the leading coefficient. We can just draw a number line and figure out where the graph is positive and negative. Now this is called a sign diagram method, and it works for not just polynomials but also rational functions. Anytime you have something with a polynomial over a polynomial. And these are the steps you're going to use. Step 1 is you need to factor px and qx. So p and q have to be fully factored, like the polynomial we were looking at above. It has to be completely factored. Step 2, you look for all the roots of px and qx. Now, px, which is the top, if it gives you a root, that's where f of x, of course, is 0. And if you get a root from the bottom, that's where fx is undefined. And we're going to plot those slightly different on the graph. Then you plot these points on a number line. You find the sign of fx to the far right of all the key points. We use what's called a test point. And then we move from right to left, crossing each key point. If the key point came from an odd power, then it's going to change the sign. If it's an even power, then we get the same sign. So let's go ahead and look at an example. And Desmos is just the nice, beautiful graph, which we, of course, gave a rough sketch for. So let's try this example here. We have 2x minus 3, and 3 minus 5x. Both of those are factored all the way, so we're good to go. From the top, we get the value x equals 3 over 2. And from the bottom, we get the value x equals 3 over 5. So 3 over 2 is going to be a little more to the right, so we can put that right there. Now 3 over 5, because it's coming from the bottom, that's a little big, we want to make it a whole, 3 over 5. Because it's not technically part of the graph, it's going to be undefined, so we put it as a whole on the number line. Now let's go ahead and test a point bigger than 3/2. So let's test maybe x equals 2. Well, we would get 2 times 2, so 4 minus 3 to the power of 4, over 3 minus 10 to the power of 2. Now, 4 minus 3, that's going to be positive to the power of 4. That's going to be positive on the top. 3 minus 10 is negative, but when you square it, it's positive. So positive divided by positive is overall positive. So we can put that right there. Now, both of these are coming from even powers. This one's coming from degree 4, and this one's coming from degree 2. So when we cross an even power, if it's positive, it's still positive. If it's positive, well, there you go, it's still positive. And there we have our wonderful sign diagram. Let's try another one here. We have x squared minus 3x plus 2, 2 minus x all squared, x squared plus x plus 1. Go ahead and pause the video and give this one a try. See if you can come up with the sign diagram. All right, assuming you gave it a try, let's look at the factored form. So this first part here definitely factors. This becomes x minus 1 and x minus 2. The next part is already factored for us, so that's good. And if we check the discriminant of this, b squared minus 4ac, we're going to get equal to, what would it be? 1 squared minus 4 times 1 times 1. That's going to be definitely negative. So it doesn't factor. And if it doesn't factor, then we just have to leave it how it is. Here we got 3 minus 2x to the 5. Now x squared plus 4, you might be tempted to factor that. But remember, it only factors when it's a difference of squares. For the cubes, degree 3, sum and difference both work. But for degree 2, it only works for the difference, and this is a sum, so this is also not factorable. Alternatively, you could also check the discriminant on this. Either way, you're going to find it not factoring. So let's go ahead and plot the points. From the top, we're going to have x equal to 1, x equal to 2, x equal to 1/2, and that's going to be even. We're also going to have x equal to, from the bottom there, 3/2, and those are all of our points. So let's test a number bigger than 2. I like to test 10. So is a nice number. You can test x equals to 10. And let's go ahead and plug it in. So 10 minus 1, that's positive. 10 minus 2, that's positive. 20 minus 1 squared, definitely positive. 10 squared plus 10 plus 1 is positive. So all along the top, we've got positive, 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 and positive. On the bottom, positive. On the bottom, we've got 3 minus 20 to the power of 5. That's going to be negative. And then 10 squared plus 4, that's going to be positive. So negative, positive. So positive times positive times positive times positive over negative times positive, you betcha it's going to be negative. Now when we go over each one of these, if it's going to be just a regular root or a regular undefined, we change the sign. So positive, negative, positive, and then if it's an even power, we get the same sign, positive. Let's do one last one. And again, I encourage you to pause the video here. Go ahead and give this last one a try on your own. So let's go ahead and factor fully. Here we have a difference of cubes because this is 2 cubed minus 3x cubed. So using our formula, we'll get 2 minus 3x, 4 plus 6x plus 9x squared. Then this is already factored for us. X plus 1 squared, 2 minus x to the 4, over, this will be x plus 2 and x minus 3. The next part doesn't factor. You can check the discriminant. It is irreducible or not factorable. And then the last part is factored for us. So let's go ahead and plot those points. Starting with the top, we've got 2 over 3. We've got negative 1, which of course is even. And we've got 2, which is also even. Now, just as a quick note, you might be wondering, why didn't we try to factor this portion here? Well, you can check the discriminant and this doesn't factor. And I'll give you 2 reasons why it doesn't factor. The first reason is this formula that we memorize for the difference of cubes is supposed to be the factoring. It's supposed to be the shortcut for factoring the whole thing. Why would I give you a formula that factors the thing, that gives you a thing that isn't all the way factored? There's no point memorizing a factor formula that doesn't actually finish the factoring job. So this works because, well, it works. It's the fully factored version of any kind of difference or sum of cubes. The other argument, if you want to think about it, is this graph here would be just your basic cubic. And so it's your basic cubic. In this case, it's opening down or it's reflected down from your basic, and it's going to be shifted up 8. But regardless, if you have a basic cubic graph, no matter how it's shifted, just your basic one, it's going to only pass through one time. If you want to have more than one factor on a cubic, you got to have a little wiggle to it so that it actually goes through 2 or 3 times. And the basic ones like this, where they're just having a reflection and a shift, only pass through the x-axis one time, which is why you only get one factor and the other portion doesn't factor. So anyways, returning to our example, in the bottom here we have x plus 2 and x minus 3, so we should add a negative 2 and a positive 3. Then over here we've got irreducible, and then we have, well, 6 over 7. 2 over 3 or 6 over 7? Which is bigger? This is a bit of a problem here. We've got 2 over 3 and we've got 6 over 7. It's a little tricky on the number line where to put which one. Now, you might argue 2 over 3 is bigger. You might argue 6 over 7 is better. If you're ever trying to compare fractions, it's always a good idea to give them the same denominator. So we could multiply them by each other. This would become 21 and 14. And then the 6 over 7 would become, well, you multiply by 3. So 18 over 21. And clearly this is bigger. So over here, we put 6 over 7. Now let's pick a number bigger than 3. Let's test x equal to 10. So looking back at my polynomial here, or my rational function, I should say, I've got 2 minus 30, so that's going to be negative. This is positive, this is squared, so it's definitely positive. This starts out being negative, but to the power of 4 makes it positive. So in the top, when I tested, I've got negative, positive, positive, positive. So we've got negative, negative, positive, positive, positive. On the bottom here, this is going to be positive, 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 and negative. So on the bottom, positive, 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 negative, which overall gives me positive, because I've got 2 negatives here that are going to make a positive. So we start on the right-hand side and put a positive, then we change the sign, same sign, change the sign, change the sign, same sign, change the sign. And there you go, your sign diagram for the rational function. So for homework, make sure you try the sign diagram worksheet, questions 1 through 19. And as always, thanks for watching.